EE-542 Teamwork Lab5 report. So in this lab, our objective is improve the TCP performance over high latency loss links by modifying the TCP stack and improve performance of the loss links by removing the exponential backoff, which is important to remove like backoff algorithm from TCP, and we need a modified TCP stack in Linux or VirtualBox. And we need also creating the kernel to modify the TCP module. For the lab producers, loss 1 and 2 are connected by the loss and the high latency link and must exchange data using TCP. And for the testing, we need to use FTP to transfer the 1 GB file over network condition, changing delay, RTT, and the package loss. For the evaluation, we need to conduct experiments using the modified TCP stack. So how do you build a kernel? To compile the Linux kernel requires a lot of disk space, and we need to assign a small AWS to have limited memory and swipe the space is necessary to support kernel compilation. And also we need to install the gate and configure it to use low memory. For the testing and modify the TCP module, so every time the kernel is compiled or modified, it's needed to repeat the configuration steps. And one might like want to try the modification on the local VirtualBox environment first to avoid like additional AWS charges. And the final experiment and evaluations. So after booting into the modified kernel, repeat the FTP SCP test. You can run a layer and measure the performance to see if change improve TCP throughput, and especially in the high latency and the package loss. So our goal is to maintain the high throughput over the network with 100 megabits bandwidth and 200 like each way. So total is 200 and 20% of the package loss.
So to improve the transfer performance, we have to build a Ubuntu kernel. And so firstly, we have to install Git on our Ubuntu servers, and we configure the Git by executing these commands, and we clone the Bionic folder to our virtual machine, which is this Bionic, and then we install the needed dependencies by executing these two commands. And after this environment is set up, and we run this command to produce the binary files, and we can generate these dep fields, .dep fields, and lastly, we can install the kernel by executing this command. And let's see. The kernel is successfully installed, and we modify the grub file to make it available for us to set the kernel when we boot up the machine, and set up these things like when we reboot, we can select the needed kernel to test our TCP transfer performance. But this is a virtual box, and we have to copy these files to the EC2 instance on AWS. So we can use scp command. We use our .pm files to use scp to copy these files to our EC2 machine, which is like this. And now we can modify the kernel when the easy to build up, and we can test the TCP performance.